Configuring a backend with a command line interface is meant for humans, and an MCP server is meant for AI. Here's how to build and deploy a web page using the Firebase MCP server. I'll be using Anti-Gravity for the demo, but any editor that supports MCP servers works just fine. Let's start by writing a prompt. Create a prototype using Next.js. Start with a sign-up page asking for name, email, and bio. When the user hits submit, have it go straight to a user profile page that displays that info with a profile picture. Keep it simple and skip a real backend. Here's the implementation plan for you to review, but it looks good to me, so I'll proceed. Now the prototype is ready. It runs by typing npm run dev. Sometimes Anti-Gravity starts the local web server automatically, visible as a running background process. This time it didn't trigger, so I'll start a terminal and run the server manually. Next, I'll open a browser at localhost port 3000 to see the result. Join the networks, it looks good. There's one small error showing up. That error comes from Chrome extensions and we can ignore it for now. Let's enter some test values. The page works nicely. If you look closely, you might spot an issue, but it doesn't matter at this stage since this is only a prototype. To use MCP servers in Anti-Gravity, installation is required first. I have the Firebase MCP server installed already, which is just a button push away. In the Tools view, you can see all the actions the MCP server can perform. Basically, they cover creating, reading, and updating anything configurable in Firebase. I recommend taking a look through them to get a clear idea of what's possible. Now comes a crucial part. When giving commands to the MCP server, use the @ symbol and then find the correct MCP server by typing either Fire or MCP. In the case of Firebase, typing a prompt without mentioning the MCP server might cause Gemini to use the command line interface instead. This happens because Firebase also has an excellent command line interface. I'll start with the first prompt and ask the MCP server to log in. I'm likely already logged in, but users setting this up for the first time might not be. I am indeed logged in. If you're not, you can easily handle it. It just opens a browser window for login, as far as I remember. After login, I'll create the project. The project acts as a central container for our web and mobile backends. Gemini says it created a new Firebase project called User Info Page Proto v1. We can go and find it with that name in the Firebase console. It's always smart to check what we have in the Firebase console. Sometimes the AI does things a bit differently. There are no apps in the project, and this is exactly what I mean. Last time I used the same prompt, I also got a web backend because Gemini guessed that was what I wanted, and it was actually correct. If we were doing this manually, we would push this button. Instead, we'll do it with the MCP server. The project needs an app with the web platform. Configure that to the project. That's done. Let's take a look at the app. Everything looks good, so we move on to the database. Create also a Firestore database for the web app. That's done. Let's review the result. It looks good. Now that the database exists, I'll ask Gemini to add the logic to store user data there. When the user signs up, the app will write the user data to Firestore. The implementation plan looks good, so I'll click Proceed. It's ready. I'll test how the app works. Here's the Firestore collection in the Firebase console. It looks like everything is working. One important thing to notice is the security rules Gemini created for us. This rule allows anyone to view, edit, and delete all the data. This setup is the same as initializing the database in test mode in the Firebase console. It's public for 30 days, and after that it denies all requests. You should never leave a database public, but before fixing that, we need to set up authentication. In the Firebase console, you can enable different authentication providers. Let's experiment with that using the MCP server. Enable Google Authentication. As expected, this isn't possible with the MCP server. In the implementation plan, it says the user enables Google Auth in the console. For security reasons, this step has to be done manually. However, the front end is ready to go. I'll try the web page. As expected, the result is Firebase error, auth configuration not found. A better process would have been to enable the authentication provider first, and then tell the MCP server I have enabled Google Authentication in Firebase console. Change the sign-up page to authenticate using Sign Up with Google. Now let's go ahead and enable Google Authentication manually. You can use your own email here or create a Google Groups email for free. After refreshing the page, it's time to test. It works perfectly. Now that authentication is active, I'll change the test mode security rules to proper production rules suitable for deployment. Fix Firestore rules so that only the logged-in user can manage his own data. The rules look good. The first part requires authentication, and the second part checks that the resource data UID matches the Auth UID. I'll test that the app still works. It works. Now that security rules are implemented, we can view the problem I mentioned after creating the first prototype. As you can see in the address bar, there are URL variables. Let's try manually changing one of them. Oh no! You can stay signed in and attempt to view any other user's profile. Luckily, the security rules prevent that, but a malicious user could still try to find registered accounts. By the way, I could have easily fixed this issue before recording the tutorial, but I purposely left it in for newer developers. It's valuable to remember that when testing any app, always check what happens when URL variables are changed manually. Fixing the issue is pretty easy. Fix the web app so that the only URL variable is UID from Firestore, and the user page is fetched based on that UID. Done. Now if I reload the page with the URL variable name equals 123, I get user not found. It shouldn't say anything other than access denied. However, the UID likely works now, so let's sign up. It works. Now we can move on to adding file storage. Create a Firebase storage, where the user can upload his profile image. The implementation plan says ensure storage is deployed. The front-end changes are done, but Gemini says it can't deploy the storage. So let's head to the Firebase console. Your data location has been set in a region that doesn't support no-cost storage buckets. The solution is to upgrade the pricing plan to pay-as-you-go. As far as I remember, no-cost storage buckets aren't available anymore in any region, but it's not an issue because Firebase Storage offers a very generous free monthly quota. I already have a billing account. If you don't, you'll need to create one. That's taken care of. Now the MCP server could create the storage, but we'll do it manually to test an important MCP feature, which is retrieving service information and updating the front end based on an existing setup. I'll start storage in test mode, and we can fix the rules later. I've configured the storage in the Firebase console. Check it out and make the necessary changes to the front end. The app is updated. Let's test it. It works perfectly. Let's check the security rules. Gemini automatically created solid rules suitable for production. Let's double-check the storage itself. The profile image is there. Now let's move to deployment. Going to the Tools view of the MCP server under Firebase init, it states, to deploy the initialize features, run the Firebase deploy command after Firebase init. Good. So the MCP server recommends using the command line interface after init. We don't actually have to care about how Gemini does it. I'll just type, prepare this app for production and deploy it to Firebase hosting. The implementation plan looks good. It's done. Here's the URL where our web app is now live on the internet for everyone to see. We've built and deployed our web app using the Firebase MCP server. Now, for anyone wondering why or when to use MCP servers in development, let's quickly cover the benefits and disadvantages. First, the benefits compared to the traditional command line interface. The CLI uses a text-based interface, while MCP uses structured data that's easy for AI to read. Reliability is high. Safety is high. Authentication is built in. Speed is faster. It might depend on the operations, but the MCP server typically needs fewer individual requests to the service. Now let's view the disadvantages. Token usage with MCP servers is very high. Cost can get expensive when using paid APIs. The level of control is medium. And the continuous context isn't a disadvantage at all. It's a big plus. That wraps up the tutorial. If you found it helpful, smash that like button.